Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll show you the use of HSM's linear machining and rest machining. If we take a look at this particular part here, I'd like to actually work on this part to use a finish cut of linear machining going across back and forth on the part itself, and I'd also like it to skip over these holes and the slot area as smooth as possible. At the end, I'd also like to finish off these corners using what we call rest machining. My first operation, I'll be going to HSM, and I'll use the option, as I said, of linear machining. And the tool that I will be using will be a 6mm ball and mill. Now, I'd like to go back into my geometry area, and in order to create a smooth tooth path over here, since I know that these radiuses over here are actually of a radius of 3mm, using the tool the way it is right now will give me a sharp turn, and this is not good for working at a high speed. So what I'll do is I'd like to create a virtual fillet around this area so the tool will pass smoothly up that part. I'll simply do applied fillets. And in my define area, I'll simply say as if we have an 8mm ball end mill going on that part. And now when I calculate that radius, you'll see that we'll have a bigger radius on the part itself. Now if I press on show, you'll note that I built a radius around the entire part. Now, I'll accept this, and I'll continue on now to my constraint boundaries. Now, the constraint boundaries I like to use in this particular area will be auto create silhouette. If I use that, you'll note that the boundary created is around the exact shape of the part, but not only that, it's also created around each hole that I have on the part itself and the slot. If I were to show you the top view of this part, you'll see the boundaries are exactly on each hole as well as around the part itself. Now I'll go into my passes area, and since it's a finished cut, I'll be using thickness of 0, and I'll be using a step over of every 1mm. Now if I go into my link area, I'll be using bidirection, and since I wanted though to jump over the slots over here and the holes as well, I'll also be using simple ordering, and I'll also go into my strategy area. Now in my strategy area we have the parameter over here called stay on surface within. I'll change this to 22mm. That means any area which is less than 22mm, such as these holes over here, it'll actually go straight to the next area instead of jumping over it. Now if I do save and calculate, and then do simulate, you'll note that the tool pass works smoothly over the part, over these holes itself. Same thing over the slots. And what I'd like to also show you is that if I zoom in, you'll note that these corners, since I added a fillet, we have now that the tool path actually works in a smooth radius fashion, allowing it to slip swiftly without any sharp corners over the part itself. Now if we take a look at the part, you'll note that over here it worked really nicely, but on these walls here it did not give a good finish. So as you can see, what we have to do is simply we have to add another option to work also on these walls itself, as well as on the wall on the other side also. What we have here is we have the option in our passes to say that we want to do a cross finish, and I'll choose the option of after. That means that it'll first finish in a linear fashion as we've seen before, and then it'll finish those extra areas as we see here in this diagram on the side. Again, I'll do save and calculate, and if we look at our simulation this time, you'll see that the tool pass, as we've seen before, will go directly across, but this time when it gets to the end, it'll come back and actually finish off this area nicely and smoothly the way it should be done. as shown over here. As you can see, it'll work on these areas, but not only that, it'll also, you can see how it actually goes over the areas where it machined before, giving it a nice smooth area. And actually you can also see over here that this area here is also curved according to the radius that I added as my fillet area. As you can see, we've finished the entire part within one operation using linear operation, and every single area has been machined correctly. What we still have to do though, however, is to finish the corners here, the radiuses themselves. Since we built a virtual radius fillet on the part of 4 millimeters, we still have to work on those areas, and for that we have the option of rest machining. So what we'll do is we'll start a new operation of HSM, and this time we'll use the option of rest machining as shown here. I'll use the exact same tool I used before, the 6 millimeter ball end mill. The constraint boundaries will be the exact same boundaries I did last time. And my reference tool, since I work with an 8 millimeter ball end mill reference tool on my fillet radiuses, this time I'll do the exact same thing, but I'll make it a touch larger so we can have a little bit of an overlap of the tool pass. Now in my passes area over here, we'll use a step down of 0.1 millimeters. And if I look at my link area, you'll note that we're working in a climb milling fashion. I'll simply do save and calculate. And if I go into my simulation, you'll note that the tool works only on the corners, working on every single fillet around the entire part. And if I zoom into the area, you'll also note how actually it overlaps between the fillets that are going horizontal to the part and the fillets that are going vertical to the part. In other words, we have a complete fillet. Every single corner is machined exactly the way it should be. From the top, from the side, every single area is machined, and now the entire part is completely finished. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.